All right, let's finish up DSMA 6, solving radical equations. Okay, so let's keep solving radical equations. We see that we have a square root. Remember, we have an implied 2 sitting right there as the index. But our x is stuck under that radical, and we need to get it out from under the radical. And so we're going to use the inverse. Because the index is 2, we're going to raise this to the second power. The entire radical is raised to the second power, but we have to do the same thing on the right side. Whatever we do to one side of an equation, we have to also do to the other side. So at this point, I had an index of 2 and an exponent of 2. That's awesome. Those are inverses of each other. That's going to leave me x minus 20. And then on this side, I get 36. And now we can just solve. So we can add 20 to both sides. And that leaves me with x equal 56. Now, again, we have to check our work. If you go on to pre-calculus or calculus, square roots are funny things. And when you start solving radical equations of even indices in those classes, you have a lot more work that you have to do. We are just going to check our answer and see if it works. So let's come over here. We are going to replace x with 56. And see if this works. So what do we get? 56 minus 20 gives us 36. And sure enough, square root of 36 is 6. 6 is equal to 6, and we're good to go. So we checked our work here. All right, so we're going to stick with this 56. Okay, we're going to solve another radical equation, but this one has an index of 3, right? And so we can't raise it to the second power. That wouldn't work. That wouldn't be an inverse. We have to raise this to the power of 3. And if we raise that side to the power of 3, we have to also raise this side to the power of 3. All right, so we're good to go over here on the left-hand side. We have an index of 3. We have an exponent of 3. So those are going to undo each other. They're inverses. And that's going to leave me just with the 12x, the radicand underneath. On the other side, if you pop that into your calculator, you're going to get negative 64. All right, so now we want to divide by 12 on both sides. And that's going to give me x equal to negative 64 over 12. We would need to simplify that. Both top and bottom are divisible by 4, and we would end up with negative 16 over 3. You also could put that into your Casio and let your Casio reduce that for you. All right, so that's not a very pretty answer, but let's see what happens when we check our work. So let's come over here and check. So we have the cube root of 12 times negative 16 over 3 is equal to, we don't know, is equal to negative 4, we hope. Okay, so if you put this in your calculator, of course you would get the negative 4, but the other thing we could do is we see that 3 goes into 12 4 times, and then we end up with the cube root of 4 times negative 16, which is negative 64, is equal to negative 4. And sure enough, the cube root of 64 is 4, and we're allowed to, because the index is odd, we're allowed to have a negative number. So we end up with negative 4 equals negative 4, and we are good to go. So not a very pretty answer, but that's okay. Don't forget, we can put the negative out front, or we can put the negative up top with the 16, but we can't put it on the bottom with the 3. All right, let's try another cube root. Now we haven't really talked about this up to this point because all of the problems were nicely set up with the radical on one side and anything without a radical on the other side. This one's not that way. So we cannot start raising to the third power. We would create quite a mess here. And so we have to do what we call isolate the radical. In other words, the radical has to be by itself on one side, and then all the numbers on the other side. Okay, so isolate the radical. The radical has to be all by itself before we start messing with raising it to a power. So in this case, let's just go ahead and add 3, put it on the other side, and then that will isolate my radical. Whoops, I didn't do that right. Sorry, this stylus does not work well of trying to erase, so I'm going to leave it be. Okay, so I have, let me make sure I did that right. -3 plus 3 gave me 0. Good, so I've got the radical by itself, and then 0 plus 3 gives me 3 on that side. Okay, now I can deal with the fact that I have a radical with an index of 3. So I'm going to do the inverse, and I'm going to raise this to the power of 3. That means I have to also raise this side to the power of 3. Okay, so on the left-hand side, I have an index and an exponent that match, so I just end up with x minus 8. On this side, I have 3 cubed, so 3 times 3 times 3, which gives me 27. And then finally, I want x by itself, so I'm going to add 8 to each side there. And that gives me that x is equal to 35. All right, so we are going to go back and check our work. We're going to check over here. But when we check our work, we always want to go back to the original problem. We do not want to go to the problem where we messed around with it a little bit. We have to go back to the original. And we want to check our work. Oops, I forgot to put the 35 in there. All right, so 35 is going to go in here. Okay, so that gives me the cube root. 35 minus 8 is 27, minus 3, and we want to know if that's equal to 0. So the cube root of 27 is 3. 3 minus 3, sure enough, I get 0 equal to 0. So that works. Therefore, I know that my answer is 35. Okay, so this looks horrible at first glance. It's not quite as bad as it looks. Luckily, on both sides, we have an index of 5. This would have created quite a problem, which you get to do in calculus if you head on to calculus, when we have different indices. But this has an index of 5 on the left and on the right, thank goodness. And so all we have to do is raise both sides to the power of 5. Remember, these have to match. It does not matter what the index is, but the exponent has to be the same. So at this point, because we have an index and an exponent matching, we get to lose the radical. And now we're going to have to clean things up. So I'm going to go ahead, I'm going to add 2x on this side. I'm going to add 1 and move it over here. And let's see what we get then. We have negative 6x is equal to negative 6. Watch me there. Negative 8x plus 2x gives me negative 6x. Good. And then negative 7 plus 1 would give me negative 6. All right. So now if I just divide both sides by negative 6, I get that x is equal to 1. Now, I'm not going to completely check my work, but I am going to just eyeball real quick of what it would look like under the radical. So under the radical, I would have negative 8 times 1 minus 1 on that side. And on this side, I would have negative 2 times 1 minus 7. So on both sides, I would have negative 9. So I'd be good to go. This would not be a pretty number. It would be an awful decimal, but at least it would be the same on both sides, right? So we're going to check there. All right, so we are good to go. Our answer is 1. All right, last equation for DSMA 6. Again, we have to isolate the radical for this one. We need that radical to be all by itself on one side. It doesn't matter which side, but it needs to be all by itself. So let's go ahead and move this 2 over to the other side. Okay, now we know that we have an implied 2 sitting here, right? We're not in the cube root right now. We're back to the square roots. So we're going to raise both sides by the power of 2 to be consistent. So we have an index of 2 and an exponent of 2. Those undo each other. They're inverses, and I'm left with 2x minus 1 on that side. On this side, I have 3 squared, which is 9. And then I'm just going to solve for x. So I'm going to add 1 to both sides. That gives me 2x equal to 10. And so x is equal to 5. All right, let's come over here and check our work. So again, when we check our work, we have to go back to the very original problem. So we have the square root of 2 times 5 minus 1. And then outside of the radical, we have minus 2. And we want to know if that's equal to 1. So we have the square root of 2 times 5 is 10, minus 1 is 9. So 3 minus 2, and sure enough, I'm good to go. I have 1 equal to 1, and therefore we know that our answer is 5. Oof, I'm having trouble making 5s today. All right.